Welcome to another engaging lecture of data representation, visualization, computational biology. In our previous session, we delved into fascinating world of diverse graphs used in data representation within the realm of computational biology. From scatter plots that unveil patterns to network graphs that uncover complex data interactions, we covered an array of techniques. In this video, we are talking our exploration, or we are going to talk about another exploration into a step forward. It's time to roll up your sleeves and delve into hands-on implementation. Theories and concepts are invaluable, but it's the practical application that truly cements our understanding. As we embark on this journey of in-depth implementation, will your guide through the complete process, whether you are an aspiring computational biologist or someone seeking to grasp the essence of data visualization. This session is designed to provide you with the tools and skills needed to create meaningful representation from raw data. In our journey to harness the power of data representation and visualization within the realm of computational biology, the choice of programming language is paramount. Enter Python, a language that perfectly aligns with our goals. Allow us to elaborate why Python stands as an exceptional choice for this endeavor. As an open source language, Python breaks down barriers, getting everyone or granting everyone the opportunity to dive into the world of data representation. Accessibility is the key, and Python's open nature ensures that resources, tutorials, and communities are readily available. Whether you are a seasoned programmer or a newcomer, the path of mastering data visualization is open for all. But it's not just about accessibility, it's also about efficiency. Python syntax is a work of elegance. With readability at its core, this simplicity of this programming language, which simply doesn't just make code easier on the eyes, but it's a boon to those focusing on the data itself. With Python, the language gets out of the way, allowing you to channel your energy into translating data even into a more insightful visuals. Perhaps the crown jewel of Python lies in its expansive libraries. Yes, you heard me right. Libraries like Pandas and NumPy are the unsung heroes behind the scene, providing a robust foundation for data manipulation and analysis. With Pandas, data can be efficiently organized and transformed, while NumPy caters to advanced mathematical and statistical operations. These tools are indispensable whether you are dealing with genomics, sequences, protein structures, or complex biological networks. In the upcoming segment of this video only, we'll again roll up our sleeves to explore Python's capabilities firsthand. We'll walk through the process of loading biological data sets, performing primarily data wrangling, and then unleashing the power of Pandas and NumPy effectively for the data manipulation. But in this particular course, we are just going to give an overall view of the data visualizations and the plots that I've told you in the last video. As we mold our data, we'll uncover trends and insights that will serve as a cornerstone of our visualization. So join me as I deep dive into the heart of Python's offerings for data representation. So by the end of this video, you'll not only understand why Python is natural fit for this journey, but also be equipped with knowledge to wield its potential to unveil the secrets hidden within the complex biological data. Let's move forward and unlock the visual narratives within our computational biology datasets. As we prepare to embark on our hands-on journey of this data representation visualization in computational biology, the first step is to ensure we have the right tools at our disposal. Installing Anaconda and Python will lay a foundation for the practical implementation we are about to undertake. So first thing that we are going to do is download Anaconda. Head over to the Anaconda website. Just for the download of Anaconda, you'll head over to the Anaconda website, a hub for data science tools and resources to kick off your installation process. Whether you are a Windows enthusiast or a Mac OS, Anaconda has covered most of the operating systems, including Windows, Mac, as well as Linux. Once you are there, simply navigate to the download section and select the installer that corresponds to your operating system. Open the installer. So with the Anaconda installer safe nestled in your download folder, it's time to take the next step. Double click the installer file to initiate the installation process. The installer wizard will greet you with a clear instructions, guide you through the setup process step by step. All you have to do is follow the instructions. So as you progress through the installation wizard, you will be presented with options to customize the installation according to your preferences. While the default settings are generally suitable for most users, feel free to explore the available choices and tailor the installation for your likings or dislikings. So once we are made our selections, give that install button a satisfying click. Now it's time to sit back. Maybe grab a cup of your favorite beverages and watch as Anaconda efficiently installs in your system. I hope you have done that. Now, the installation process might take a few moments, but anticipation of what's to come will make the wait worthwhile, of course. I'm hoping that you have already done the installation process. Now that Anaconda has comfortably settled into your system, it's time to get acquainted with the arsenal of data science tools. Locate Anaconda Navigator in your applications or applications menu and give it a click. For example, you can just click on the start button, you can find Anaconda, just search it, you will find it. This hub is your gateway to the world of possibilities in the realm of data manipulation, analysis, as well as visualization. After you have done it, now we'll start our coding with Jupyter Notebook. Yes, it's not Jupyter Notebook, it's Jupyter Notebook. Yes, within Anaconda Navigator, a familiar friends await. His name is Jupyter Notebook. This interactive coding environment is where magic truly happens. With its seamless integration of codes, visualizations, and explanatory text, Jupyter Notebook sets the stage for your data representation endeavors. As you venture into the world of Jupyter Notebook, remember that it's not just about writing codes, it's about creativity and exploration. Whether you are a coding enthusiast or new to the world of programming, Jupyter Notebook encourages experimentations and learning as you bring your data to life through visuals. With Anaconda, Python, and Jupyter Notebook at your fingertips, you are ready to dive into the foundational element of coding: data types and variables. These cornerstones will be crucial as we embark our journey of implementation, data representation, and visualization in the realm of computational biology. The first thing that we are going to talk about is data types, though we are not going to code deeply into it, but you should know it. Python, a language renowned for its versatility, offering a diverse spectrum of data types. They are strings, integer, floats, booleans. Each type holds a unique purpose and significance. This diversity grants developers the freedom to choose the data type and best align with the nature of their data and the operations they intended to perform. Whether you are working with gene sequence, numerical measurements, or categorical informations, Python's array of data types ensures that you have the tools needed to accurately represent your data. The ability to match data types with the characteristics of information being represented is essential for both accuracy and efficient computation. Now let us talk about the variables. Yes, you heard it right. In the world of coding, variables are akin to containers that holds the precious cargo of data. These containers allow us to manipulate, analyze, and visualize information with ease. Python, a dynamically typed language, possesses a unique trait, loose typing, which does no. What does this mean? It means that Python determines the appropriate data type of a variable automatically based on value assigned to it. This flexibility of a double-edged sword, like in a programming language like Python. So, on the other hand, it liberates us from the meticulous task of explicitly declaring data types, allowing for a smoother coding experience. At the same time, it places a certain responsibility on us as programmers to mindful of data we assign to a variable, ensuring the consistency and integrity of data as it flows through our code is a skill that will be honoring as we proceed. So as we progress through the immersive journey of data representation and visualization, we encounter two powerful constructs. They are array and list. These tools will be our allies in managing and manipulating data, enabling us to sculpt our biological data set into coherent visual narratives. So first thing, let us look about the links. Again, we are not going deep into the code of it, but you should be aware of it when we are actually talking about the Python. Think of list as a versatile container that can hold an assortment of items, whether they are strings, numbers, or other objects. The beauty of lists lies in their ordered nature. The sequence of items remains intact, allowing us to preserve the inherent relationship between the elements. This makes list particularly suitable for sorting sets of related values. So now just close your eyes and imagine. Imagine you are dealing with a gene expression data sets. With list, you can encapsulate the gene names corresponding to expression levels and associated annotations in a cohesive manner. This organization ensures that the biological context is retained, setting the stage for insightful visualization. I hope you understood it in a very good way. Now let us talk about the arrays. While array might share similarities with list, they possess a distinct purpose. Arrays are tailored for numerical operation, making them indispensable when dealing with extensive data set that demand effective computations. Array offer advantages in terms of both performance and memory utilization compared to the list, especially when handling substantial volumes of data is required. Now consider the scenario of analyzing DNA sequences. Array became invaluable for storing sequences of nucleotides or amino acids. Please pardon me if I'm pronouncing any of the biological names incorrect, because again, I'm not the biological no, I don't have lots of biological knowledge. I am the computer scientist, I'm the data scientist. Okay, the inherent numerical nature of these sequences aligns seamlessly with array operations, facilitating tasks such as sequence alignment, motif recognition, and more. As we journey deeper into the realm of computational biology, you'll witness the symbiotic dance between list and array. List keeps our data organized and structures, while array empowers us to process and analyze data swiftly, unlocking hidden patterns and trends. Before we delve deeper into the realm of data representation, let's make sure you are ready to code. Open your Jupyter notebook and follow the steps. First thing, you have to launch the Anaconda Navigator. Start by opening Anaconda Navigator from your application or applications menu. So you'll click on the start button, you'll search Anaconda Navigator, you will find it there. This serves as a gateway to the world of data science tools. After you open the complete Anaconda, select Jupyter Notebook from it. Within Anaconda Navigator, locate the Jupyter Notebook icon and give it a click. This action will launch a web browser interface displaying your local file system. I hope you are following me and you have done till now. Now I'm moving ahead. After this, now that Jupyter Notebook is up and running, let's navigate to the directory where you want to work on your project. So for example, you can create a new directory. If you haven't already, create a dedicated directory folder of your project. This organization will help you keep your files neat and organized. After that, you'll navigate to Jupyter. In the Jupyter Notebook interface, use the file navigation pane to find your newly created directory. Click on the directory and open it. And if it's confusing for you, no need to create a directory and all, just go to desktop and do whatever I'm saying. Now you are in the desired directory. So those who have not done anything, you are at the desktop. Let's create a new IPython notebook, also known as Jupyter Notebook. So now in the Jupyter Notebook interface, you will see a new button, NEW, new button. Click on it to open a drop down menu. From the drop down menu, select Notebook Python 3 or a similar option. This will open a new Python notebook in a new tab. The first thing, I hope the new Python is open in your tab. Now the first thing that you'll do, again, remember it's it's not a difficult thing, it's a very easy thing. So it's very important that you follow whatever I'm saying and whatever you're seeing. Now you have to rename the notebook. On the top of the notebook, you'll see untitled. Click on this particular thing and rename your notebook to something meaningful. This will help you track your projects. For the time being, let's name it as plots. Before you utilize anything else, now we have to go and utilize the matplotlib to create captivating visualization. We have to make sure it's installed in the Python environment. Within your new Python notebook, you will see a cell with an in brackets label on the left. This is where you will write and execute your Python codes. In the cell, you have to type pip install matplotlib and press shift enter. You can also use the run tab from above, but for the timing, just learn some shortcuts from me. Just press shift and enter. This command uses something to run a cell command within the notebook, installing the matplotlib library. So the moment you will write pip install matplotlib, it will install a matplotlib for you. I hope you have done it. Now you are all set. With the Jupyter notebook open, your directory organized, and IPython notebook ready to go and Matplotlib installed, you are well equipped to delve into the world of data representation and visualization in computational biology. As we delve deeper into the implementation of this fascinating visualization, let's examine every line of the code piece by piece so you can see the complete codes. I'll try to explain each code piece by piece to unreveal the details that of the chart that brings the chart into the life. Now you can see this Python code. Look at this code very deeply. First, we have written import matplotlib.pyplot as plt. What we are doing, there is someone who has already developed and someone who has already done a lot of work for you to create certain kinds of visualization that is inside the matplotlib pyplot, and we are just installing as in the form of plt. This journey start by importing the matplotlib.pyplot module, a powerhouse for creating a myriad of plots and charts that will give you visuals from our data. After this, the second code or the second chunk of code that you can see in the Python is bird species is equal to sparrow, robin, blue jay, and cardinal. This all are four types of species that we have mentioned here, and in the second way we have an array that is observations. So for example, the number of sparrow is 45, robin is 32, blue jay is 18, and cardinal is 23. Here we establish two fundamental lists. Bird species carries the names of the various bird species, and the observation tallies the number of observations for each species. Let's move on to the next Python code. Remember, when I'm telling you this particular Python code, you have to keep on writing this codes. If you're not writing this code, you are actually not learning anything. So you have to write this codes. After that, we have years, which are 2010, 2011, 2012, and 2013. And next is the bird population, which is 1500, 1400, 1600, and 1300. The year list encapsulates the year under study, while this bird population record the corresponding population number of birds. Again, if we go to the next part of this particular code, you can see wingspan and body weight. Wingspans are 10, 12, 15, and 14. Body weights are 25, 30, 40, and 35. This all data is a dummy data that I have given, but let's try to visualize it. So enter wingspan and body weights, spotlighting wingspan and body weight values across different bird species. This we are just trying to input certain behavior of this particular birds. Next code, we are implementing the feeding behaviors of the birds. So we can just categorize them into herbivorous, carnivorous, and omnivorous. Again, feeding percentage, how many of them herbivorous, carnivorous, and omnivorous, which is 35, 25, and 40 respectively. A dive into feeding behavior reveals the various ways birds feed, matched with the various respective percentage distributions in feeding percentages. Now, we can see the next code. Remember, again I'm reminding you, please keep on writing these codes. Next is altitude and latitudes. Altitudes can be low or high, latitudes can be north or south, and species presence, which can be 0, 1, 2 or 1, 2, 3, 1. Remember, this is a nested type of array, so we are trying to kind of make it like a matrix. I'll explain you everything, don't worry. And then latitude, altitude and latitude mark this altitude and latitude categories. Meanwhile, species presence paints a picture of species presence based on altitude and latitude indices. Let's move to the other block of code wherein I have given you the plot figure. See, PLT. Remember, we have imported the matplotlib as PLT. Now we are using that PLT word. We are using PLT.figure. Figure is a function that is pre-made. Someone has already created it for the ease, for your ease, and we are just using it, and we are giving figure size as 12 and 8. That's okay. With a touch of artistry, we set a stage by defining the size of the figure 12 units wide and 8 units tall, something of that kind. After that, we are writing a code like plt.subplot 2, 3, 1, plt.bar, which indicates that we are going to create a bar plot, in which we are taking bird species, observations, and color is equal to sky blue. See, since we have birds, we are taking the color as sky blue. After that, we have plt.title, which is plot title, bird species observation, we are giving it a title, and plt.y label, we are giving y axis. You must have already gone through the various charts, so it's a y axis of the chart in which we are writing observations. In the first subplot, a canvas is born, a bar chart emerges with bird species on the x-axis and observation on the y-axis. The bars are adorned with the tranquil sky blue hue, with titles and labels are meticulously placed. After this, if we see the next codes of our Python, it's plt.subplots. Now we are having something plot within the plot, which are kind of subplots. Don't worry if it's confusing for you, just try to play with these codes. Just try to write the codes in your Jupyter notebook, just play with it. You will be understanding all the things in a very clear way. After that, we have plt.plot. Now, what are two things that we want to plot? What are the markers that we want to use in the plot that we are telling here? What are the color that we want to plot that we are here? After that, we are giving it a title, X label, and Y label. X label is of course years and Y label is population. Behold the second subplot, a landscape of lines. Here we draw a line chart with years as a backdrop and bird population as the stars. The sprinkle of circular markers adds flares and the shades of green paint in the path. Titles, x-axis and y-axis labels complete the composition. After you can see plt.subplot 233, where now we are trying to develop a scatter plot. plt.scatter, wherein we are trying to give two parameters, wingspan and body weight. The color we are trying to give it as a purple and the marker as S. So the title is wingspan versus body weight. The third subplot unfurls, showcasing a scatter plot wherein wingspan takes the lead on the x-axis while the body weight assumes its place on the y-axis. The purple hue radiates with markers shapes like squares, and that is why we are writing S here. Captivating titles and labels add depth and context. Now you can see this subplots again for feeding percentage and feeding behaviors. Similarly, these are the similar types of charts that we are in. You just need to try it on your end and you will be very good at it the moment you play with it. Now welcome to the fourth subplot, a delicious slice of pie charts heaven. So feeding percentage is the recipe with the feeding behavior as labels, a touch of formatting flares with autosipity, the percentage display and strangle for initial tilt, hues of golds, light coral and light green paint, visual feast, a title tops of the presentation. After that, this next plot is related to another chart, and that is subplot number 5, a canvas of color and data. Behold the heat map created by plot.im show, where species representation is masterpiece. YGM petal adds the depth, while axis customization with X tickles and uh, X ticks and Y ticks fine tunes the experience. The title crowns the pieces, and the color bar stands as the legends of the observation. Again, in the next Python plot, we are just a final touch in the curtain call, in which plt dot tight layout ensures that the subplots harmoniously coexist with the figures, each having moments of spotlight without overshadowing with others. In the end, we use plot.show generally to show the plot. It is a very essential part of it. With this meticulous dissection of the artistry behind each line becomes apparent. Each line is a stroke of brush adding to the grand canvas of data representation visualization. Is through this code, the raw numbers, metaphors with the captivating insights that resonate with the essence of computational biology. And there you have it. Through exploration of the magic behind the data representation and visualization using Python in the realm of computer biology, from importing library to crafting intricate visualization, each line of the code is a brushstroke that brings your data to life. But remember, as with any craft, practice makes everyone perfect. The more you immerse yourself in this journey, the more your skills will flourish. Start with the simple challenges and gradually work your way up to more complex data sets. Each step you take will deepen your understanding and fineness, your ability to transform data into captivating visualization or visual narratives. So embark on this coding adventure with confidence, embrace the challenge, celebrate the breakthroughs, and let your creativity flourish. With dedication and practice, you are born to master the art of data representation and visualization, unveiling the computational biology on one chart at a time. Looking forward to your next, of course, our next meeting in the upcoming video. Until then, keep coding, exploring, and diving into the world of data representation and visualization. See you soon.